Okay, today we're going to be seeing if liquid water can float on liquid water. So I've been asked this question a lot in the comments section, so I thought I should do a video on it. Okay, so in order to do this, I'm going to take a sample of this water that I have here. So this is the same water that I had in here, but now I just colored it green so you can see it. So let's see what happens when I stick it in the water. So it doesn't float or sink. It just stays right where it is. But what happens if we change the temperature of it? In my red cup I have hot water, and in my blue cup I have cold water. And in the middle here I just have room temperature water. So what do you think will happen when I put my cold water in there? Well, let's check it out. It just drops to the bottom. Now let's see what happens to the red, the hot water. And that just rises to the top. So the answer to the question, does liquid water float on liquid water? The answer is definitely yes, because it depends on the temperature of the water. So warm water floats on top of cold water. But that's only true for a certain amount of time. If you get this water any colder, then it stops sinking to the bottom. In fact, once it drops below freezing, then it doesn't sink at all. So I have here some freezing water. Some people call it ice. So a really cool experiment to show the density of water changing from solid to liquid form is to put ice in oil. And basically what you do is you just combine these two to get the right density that you need so that your ice essentially stays right in the middle. It doesn't float or sink. And when you do this just right, you can show that your ice, when it becomes liquid water, becomes more dense and falls to the bottom. So this is really cool. So you can see the solid ice just kind of staying stagnant, and then the liquid ice just drips down. So this shows very clearly how liquid water is much more dense than solid water. So notice how it bobs up and down when it drops the drops, because as it melts, a drop comes off and it starts to pull it down because it suddenly got more dense. So that's what's weird about this. Just by changing states, the water essentially weighs more in the oil than it did before. So if I had a scale in this oil and I were to weigh an ice cube, it would weigh more after it melted than before it melted. So then the question is, if you have a glass that's completely full and you have ice in your glass, because ice floats, some of the ice is pushed up above the water. So what happens when all of that ice melts? Will it overflow the glass, or will the liquid level stay exactly where it was? If you have any guesses, leave your guess in the comment section. Let's go ahead and find out what happens. So I have around 430 milliliters of liquid water, and then I'm gonna add ice to it. So the liquid level is now at 730 milliliters. But you can see that there's a considerable amount of ice above the liquid level. So does that mean that when this ice melts, it's going to raise the liquid up? Or will it just stay exactly where it is at around 730 milliliters? Well, let's wait for the ice to melt and see what happens. You can see that the ice is about completely melted now, and the water level is still exactly at 730 milliliters. So where did all this volume of ice go that was on the top? How come it didn't raise the liquid level? And so basically that entire volume of solid water that was above the liquid line actually got compressed into no volume when it turned back into solid water. And so even though it seems like that amount of ice that was floating above the level of the liquid water should be added to the total volume, it actually doesn't, just because of the density changes of the water as it turns back into liquid. But this should bring up a question for you. You may have heard recently that some scientists are concerned about the melting ice caps of the Earth because they say that when the ice caps melt, it's going to raise the water levels of the entire ocean. But I just showed you here that when floating ice melts in water, it doesn't raise the level of the water. So are these scientists just crazy? Well, there's one difference between this experiment and the ocean, and that is that the ocean is salty. So let's see what happens when we use salty water instead of fresh water. Okay, so we have around 400 milliliters of salt now. Now let's put our ice in. So the water level is at 620 milliliters. It's kind of hard to see, but you can see the line right there, 620 milliliters. So you can see as it's melting, it actually looks like it's going up a little. It's not around the 620 mark here, but it's at around the 630 mark now. Let's see what happens when it gets all the way melted. So what's going on here? Why did fresh water not increase, but salt water made it increase when we put ice in it? Ice in the ocean is nearly salt-free because of a process that's called brine rejection. And that just means that the salt from the seawater doesn't enter the crystal structure of the ice. And so what that means is that all of the ice in the ocean is fresh water, while the sea is salt water. And salt water has a mass of 1.026 grams per centimeter cubed instead of 1 gram per centimeter cubed, so it's a little bit more dense. And because all of that ice is fresh water, when the fresh water melts into the ocean, it decreases the salinity of the ocean. And because less salty water is less dense than salty water, the volume of the ocean actually expands. And so in the scenario of the ice caps melting, the total mass of all the water that's in liquid and solid form doesn't change at all, but the volume actually increases. So basically, ice floating in salt water will increase the level, but ice floating in fresh water will not increase the level. Hey everybody, thanks for watching another episode of the Action Lab. I hope you liked it, I hope you learned something. If you did and you're not subscribed yet, remember to hit the subscribe button, hit the bell to be notified when my latest video's out, and I'll see you next time.